Good morning students. Today in this video we are going to see about phenols, that is preparation of phenol and properties of phenol. So we know the formula for phenol C6H5OH. So this group is, we call it as a C6H5 and this is OH group. So hydroxybenzene is the IUPAC name and the common name is phenol. So hydroxy means OH group, benzene this one. So hydroxybenzene is otherwise called as phenol. So for the preparation of phenol, there are four methods. All the four methods are very, very important. So first we are going to see the name reaction is called Douse process. So when chlorobenzene, that is C6H5Cl, when chlorobenzene is hydrolyzed with a 6 to 8% sodium hydroxide. This is when reacting in chlorobenzene, when reacting with the alkali, that is 6 to 8% sodium hydroxide at 633 Kelvin and 300 bar, that means atmospheric pressure. First it forms this Na and this Cl goes as NaCl. This OH group, that is this H and Cl remove as HCl. This ONa group go and attaches here to form sodium phenoxide. This hydrogen and this chlorine is removed as HCl. Remaining part ONa join at that is benzene group, so to form sodium phenoxide. Then which is on further treated with the HCl, this Na and Cl remove as NaCl, this H go and add to form phenol. So here in this reaction the very important one is temperature as well as pressure is more important, we should not change. Keep them in mind, 633 Kelvin and 300 atmospheric pressure. So when chlorobenzene is reacting with the sodium hydroxide, under these conditions, first it forms sodium phenoxide and further hydrolysis with the HCl to form phenol and NaCl. So this process is called Douse process for the manufacture of phenol. Then second process is from benzene sulfonic acid. This structure we call it as a, so benzene ring. Sulfonic acid means H3S, that is here SO3H group. So benzene sulfonic acid when reacting with the sodium hydroxide, here also it forms similarly like sodium phenoxide and further treated with the HCl forms phenol. So from benzene sulfonic acid also we can prepare phenol. Then third one is name reaction, which is called as diazotization reaction. Diazo, that is called as N, double bond N, means diazotization reaction, that is from aniline how we can prepare phenol. So aniline structure C6H5NH2. So amino benzene or otherwise called as aniline. So when aniline is treated with nitrous acid, that is HNO2, aniline is diazotized with the HNO2, that is nitrous acid. HNO3 means nitric acid, HNO2 means nitrous acid at 273 to 278 Kelvin. More or less it is a 0 degree Celsius temperature. To give benzene diazonium chloride, this is benzene diazonium chloride, C6H5N2Cl. This N double bond N group we call it as a diazo. So benzene diazonium chloride. Then further hydrolysis it forms this H will go, this O and H comes in here, add here. Then one more H and Cl goes as HCl and this N and N comes as N2. So phenol plus N2 plus HCl. So third preparation is from aniline. The name reaction call it as a diazotization reaction, and when aniline is treated with the nitrous acid forms benzene diazonium chloride, which on further hydrolysis to forms phenol and N2 and HCl. Next, the fourth method for the preparation of phenol is from cumin. So very, very, very important question and also important for problems also. From cumin, how will you synthesize phenol? So first we have to take benzene and propene. So when benzene C6H6 when reacting with the propene, first it forms cumin structure. So cumin structure is a benzene ring. Here one, because in all the position there are 6 carbon and 6 hydrogen. So one hydrogen from this side goes and add here to form CH3. So this double bond will open. Now CH, here also CH3, here also CH3. Now it attaches with the benzene ring. This structure we call it as a cumin. So benzene ring with the CH and 2 CH3 groups attached. So there is isopropyl, that is 1, 2, 3. This is a propyl benzene. We call it as a isopropyl benzene is otherwise called as cumin. So from this cumin, how will you prepare phenol? So for the preparation of cumin, we need benzene and propene. These two react at presence of phosphoric acid, that is H3PO4, as a catalyst and forms first cumin. On air oxidation, that is in presence of air, on oxidation with that is sodium carbonate. So here O2, this O and O, two oxygen atom goes and attaches with between carbon and hydrogen. See here, carbon and hydrogen, this two oxygen is there. So it forms a cumin hydroperoxide. So then cumin hydroperoxide and hydrolysis with the sulfuric acid, it forms, see this OH group alone, this OH goes and add with the only benzene ring to form phenol, and remaining CH3, CO, CH3 comes as acetone. So from cumin, how will you synthesize phenol? It's a very, very important question. First formation of cumin, then cumin hydroperoxide, then acid hydrolysis, it forms the phenol and acetone. That's all about the preparations of phenol. There are 4 processes. One is from Douse process, second one from benzene sulfonic acid, and the third preparation is from aniline, that is called diazotization reaction, and the fourth one is from preparation of phenol from cumin. Next we are going to see about the properties of phenol. Next we are going to see about the properties of phenol. So in properties, there are few reactions based on the reaction due to OH group, and the next few reactions due to the benzene ring. See here, the first type of property is due to OH group. That means in benzene ring, C6H5, then one OH. So only the reaction is due to OH group. There is no change in the benzene ring. So under these heading, we are going to see about 6 or 7 types of reactions. So first one, convert phenol to benzene. So first reaction with the zinc dust. Zinc is a metal which is a good reducing agent. Reducing agent means removal of oxygen atom. So in phenol, when it is reacting with the zinc dust, that is zinc metal, the zinc takes up only the oxygen atom alone to form a zinc oxide, and this hydrogen atom goes and add here to form as a benzene. So for the conversion of phenol to benzene, just we have to add zinc metal. Second reaction is with ammonia. Phenol, when reacting with ammonia, the presence of anhydrous zinc chloride, it forms aniline. Here OH group is there, here one H. So here OH group and this hydrogen atom goes as water molecule. Remaining group is amine group, that is NH2, goes and add here to benzene to form amino benzene, or otherwise we call it as a aniline. Then third one is Cotton-Bowman reaction. This is a name reaction. Here phenol, when reacting with the acetyl chloride, CH3COCl, acetyl chloride, presence of sodium hydroxide and pyridine molecule. Here it forms just only the removal of HCl. Here one H, here one Cl, removes its HCl, and remaining C6H5O, then CO, CH3. So it is names called as benzyl acetate. Benzyl C6H5, then acetate formula CH3COO. So benzyl acetate. So it is also called as a esterification reaction. Name is Cotton-Bowman reaction. The next important reaction is Williamson ether synthesis. So very, very important name reaction. When phenol is treated with a sodium hydroxide, that's why here given the alkaline solution of phenol. That means this mixture. Alkaline solution means sodium hydroxide reacting with the phenol. This alkaline solution of phenol reacts with the alkyl halide. That is alkyl halide. This is so after the formation of sodium phenoxide reacting with the alkyl halide, that is methyl iodide, to form phenyl ether. This first phenol reacting with the sodium hydroxide forms sodium phenoxide. Then with reacting with the methyl iodide, that is alkyl halide. Here Na, here I removes NaI. Remaining the CH3 group goes and add here to form methoxybenzene. This is called as anisole. This is methoxy. CH3O group is called methoxy. This is a ether. O linkage means it is an ether. So methoxybenzene is a IUPAC name, and common name is anisole. So in this page we are seeing only the reactions due to OH group, reaction with the zinc dust, with ammonia, this Cotton-Bowman reaction, and Williamson ether synthesis. Then continuation, there is a fifth reaction is oxidation. Just phenol, when reacting with a powerful oxidizing agent such as acidified, this is acid mixed. So acidified potassium dichromate, this K2Cr2O7, it forms a benzoquinone, ONE, this is a keto group, double bond O, here also double bond O. It forms a 1,4. So first, second, third, fourth group. So first position, fourth position having a this one group. So it forms a 1,4 benzoquinone. So phenol and oxidized with a powerful powerful oxidizing agent, it forms 1,4 benzoquinone. Then this is oxidation. So removal of hydrogen takes place. But here reduction reaction. See, phenol on catalytic hydrogenation. Reduction reaction means addition of hydrogen. See, the 3 into 2, 6, totally 6 hydrogen. The 6 hydrogen goes and add here to form, in the here only CH only. But when it is added 6 hydrogen atom to this phenol molecule, it forms a cyclohexanol because all positions having 2 hydrogen atom. So addition of hydrogen takes place in the presence of nickel as a catalyst. So this reaction is a phenol on catalytic hydrogenation. Addition of hydrogen takes place, gives cyclohexanol. So phenol reacting with the 3 molecule of hydrogen, presence of nickel, under 160 degrees Celsius, it forms cyclohexanol. The next, the reactions due to benzene ring. So last we saw the reactions due to OH group in the phenol. Here the reactions due to benzene ring. So these are also chemical properties of phenol. Here there is no change in the benzene OH group. Just which reactions takes place only in the benzene ring. So that's why reactions due to benzene ring, not due to OH group. So for that, first nitrosation reaction. Nitrosation means in the heading itself, the reaction is with nitrous acid. So nitric acid formula HNO3, nitrous acid formula HNO2. So when phenol, when reacting with the nitrous acid at 278 Kelvin, here only it undergo para position takes place. Para means just a functional group opposite position is called para, near position, adjacent position is called ortho, and alternate position is called meta position. So here nitrous acid, the NO group, it is electrophile only attacking the para position. So it forms not NO2, only NO. So the reaction, the name is called para nitrosophenol. Second, nitration reaction. Nitrosation means nitrous acid. Nitration means nitrating mixture, that is with the when phenol reacting with 20% nitric acid at 298 Kelvin. So only nitric acid. It forms ortho as well as para. So ortho product, ortho nitrophenol. This is NO2 group is called nitro. Ortho nitrophenol and para nitrophenol is obtained. But when we comparing the percentage of yield, 30 to 40% yield will be obtained only from ortho nitrophenol, because NO2 group is a ortho orienting group and NO group is a para orienting group. The next very important question, what is picric acid? How it is prepared? What is its chemical name? See, when phenol is reacting with a nitrating mixture, so nitrous acid, nitric acid, here nitrating mixture means it is a mixture of con H2SO4 and concentrated nitric acid. Both the mixture keeping them as a 298 Kelvin, it attacking all the, that is 2 ortho position, that is NO2 and para position also. So when we come giving numbering here 1 means, so 2, 3, 4, 5, 6. So 2, 4, 6, 3 NO2 group is there. So trinitrophenol. So 2, 4, 6 trinitrophenol is called as picric acid. Even though it does not contain COOH group, acid group, but we only OH group and NO2 group is there, even though it is called as a picric acid, because that much powerful to liberate the H+. We know acidity means the substance which readily releases H+. That's why here also the picric acid, the hydrogen atom easily removed and it forms a phenoxide ion. That's why we call it as a picric acid. So what is picric acid? How it is prepared? Very, very important. 3 mark or 2 mark question, or subdivisions in 5 mark it will ask. So its chemical name is 2,4,6 trinitrophenol. The next reaction is sulfonation. Sulfonation means only concentrated sulfuric acid. So here also the SO3H group. These are all electrophile. So the electrophile group SO3H from here, and it attacking only ortho as well as para. So it forms orthophenol sulfonic acid and paraphenol sulfonic acid. The next halogenation reaction, that is with the bromine water. This is also a test for phenol. So when phenol is reacting with the bromine water color is yellow color solution. When it is treated with the phenol, it forms a, because here 6 bromine atom is present, 3 bromine molecule, but totally 6 bromine atom is there. So in 3 positions 3 bromine atom is combined, and remaining 3 takes away this H to form as a 3HBr. So 2,4,6 tribromophenol, it forms a white precipitate, and it gives a precipitate substance, and also it is a test for phenol. So phenol reacting with the bromine water, the bromine water color decolorises and changes into a white precipitate of 2,4,6 tribromophenol along with the HBr. And also when bromine reacting with the water, it forms a tribromophenol. Similarly, when phenol reacting with the bromine in the presence of here polar solvent, and this one is a non-polar solvent, that is carbon tetrachloride. It forms 2 separate molecule, orthobromophenol and parabromophenol. So today we saw about the preparations of phenol and the properties of phenol due to OH group, and the properties of phenol due to the benzene ring. And there is also some more reactions are there, like Kolb, Riemann-Tiemann, Tallinn reaction, coupling reaction, test for phenol and uses of phenol. This we will see in the next video. Thank you, students.